Test-Driven Development with James Grenning.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. And it's a lot of fun getting on the schedule for .NET user groups. If you run a .NET user group, I'd love to get on your schedule to do a virtual presentation. If you're tuning in for the first time, the Azure DevOps Podcast is for developers shipping software with Microsoft technologies. And my goal for all of you, for all development teams, is to be able to move fast, deliver quality, and run your systems with confidence. ClearMeasure, the sponsor of this show and my employer, is hiring. And if you're a .NET developer and are on a track to become an architect, we want you. Just apply on the website. 4 positions are available. And my host today is James Grenning. He is one of the original authors and signatory of the Agile Manifesto. His company is Wingman Software, and he coaches and trains developers to deliver better and more. His specialties include test-driven development and embedded software, going deep in C-based embedded technologies. James, welcome to the show. How are you, sir?
I'm good. How are you doing today?
I'm really great. I'm excited to be talking with you and just have you explain to everyone what test-driven development is today in 2020 and how it's changed over the decades. But there's a lot of people familiar with your work. But for those who aren't, what was it like at the turn of the millennium and when conversations were just starting and the Agile Manifesto was just an idea in a few people's heads?
Well, the way I like to kind of characterize the 90s were we were paying attention to Watts Humphrey's book, Managing the Software Development Process. And in that book, the message we were getting was if you had a better process, the people wouldn't matter. And I kind of have always had an affinity towards processes. And so when I started to see extreme programming, I'm thinking, wow, this is a great way to work. And one of the things about extreme programming in the late 90s, its name got people to go and see what it was. It's kind of funny, elbow pads and wearing extreme. A helmet and stuff, because extreme sports were kind of getting their start then. And so extreme programming was, kind of interesting play on words there. So that got us interested in it. And from my perspective, it seemed like it solved problems in development that I had experienced for the previous 20 years. So I've got about 40 years of development experience right now. In the first 20 years, I did what I now jokingly call debug later programming. And since then, I've been doing test-driven development. And So Agile Manifesto, that meeting, there were none of these ideas rattling around, like those bullet points weren't rattling around in anybody's head that I knew of before going to that place. What the times were is processes were getting bigger, and some of us saw this other thing, which was processes could be smaller. And as a matter of fact, the name of the meeting, you probably have heard this from somebody else before, but it was the Lightweight Methods Summit. And so I always tell the truth on why I was there. It was in Snowbird, Utah, and I love to ski. I've skied most of my life. And Bob Martin, who I worked with at the time, invited me to join that meeting. And so that's how we got there. Now, and the group of people, it's kind of interesting, diverse group, but there was a XP contingent, which I was part of with Kent and Ron and Ward and Martin Fowler, Bob Martin. We were all kind of part of that gang. And so we were, there to talk about that. And then we were hearing about things like Scrum and FDD and, some of the other flavors that have fallen under the umbrella that, Agile name is. I've probably talking too long.
No, this is all good context. And I think this is important because I run into a lot of people who use the term Agile, and then I'll say, hey, has all of your team read agilemanifesto.org? And they'll look at me and it's like, what's that? And they hadn't. And so there's a lot of people out there, and I've looked at the stats. Longtime listeners know that I like to quote stats and data. In the last 7 years, we have twice as many developers in the industry as we did 7 years ago. And so that means that half of the developers writing software today were not in this field in 2013. So there's this bit of history that half of our industry is in various stages of knowledge.
Yeah, that's an interesting. I think Bob Martin uses a similar number. I think his math showed it was 5 years, but at any rate,
yeah,
most people don't have much experience at this. And, just kind of reacting to what you said there, it was kind of interesting. A friend of mine, Kevlin Henney, he's a speaker in the UK and an amazing engineer. And he did a talk about old is the new. And he read I think it was a NATO paper where there was Dijkstra and a number of the other founding fathers there, and all the problems they're talking about are the same problems we have today. And the solutions that they had were, kind of like some of our solutions today, but in a way, there's nothing new. History repeats itself.
Right. So you've gone super deep into test-driven development, which is part of the extreme programming bundle of engineering practices. From a philosophy perspective, for people who want to be highly productive, and then the age-old argument, I don't have time to do all that stuff, we need to go fast. How do you explain the arguments that impose speed and quality against each other?
Yeah, well, so what I typically do when I'm helping somebody that actually has gotten to the point of either their boss is making them come to my training, or they did enough study to say, I think this would really help. What I try to help them through is seeing what it's like to program with fast feedback. And one of the problems, so if I wrote this blog 15 years ago or something. Most of the people doing development now, I guess, weren't even doing development then, by your stats. I call it debug later, the physics of test-driven development. And I draw out a timeline of debug later programming on one timeline, which is person makes a mistake. And the mistake goes undiscovered, later to be discovered, and now becomes a bug. And, if you find it yourself, maybe it's not a bug, but if anybody else found it, now it's a bug. Or maybe your customer found it and it was code that was written 5 years ago, or maybe it was written 2 months ago. But my rhetorical question is, how long does it take to find the cause of a bug? And everybody looks and they throw up their arms. It's like, there's no knowing. We have some that we can't find the cause to. Mm-hmm. So you live with that possibility in development. Even if you did test-driven development, you still have that possibility. Although there's something you could do to avoid that. And so there's a test-driven development feedback cycle, which is instead of making a mistake, not realizing we made a mistake, having somebody find it later, maybe me or maybe somebody else, and then having to find it at a large uncertainty, we work in a tight feedback loop. Small steps. I wish I would have known 40 years ago how important small steps were. It's really taken quite a while to actually really understand how important they are. Test-driven development made that possible for me to understand it. But you say, I wish the code did this, and you write a test about that thing you wish it did, and it won't do that. Okay, well, then you go make a little change to make it do that. And if you get good at this, you can grow the behavior of something from a very simple start to the full, rich completeness that you need. And as you change your mind, which of course you will, you can then, you have the test to keep the behaviors that you want alive as you make changes. You get automatic retest of everything. And then you can add in the new things you want. And maybe you have to start to split software up, but you can do that safely because you have tests.
And for the people who have never done test-driven development before and maybe don't even know where to start, maybe they're one of the younger people and they haven't heard it,
or one of the older ones.
Yeah, I found the older ones have heard it and they just like, I don't want to mess with that.
Yeah.
But with younger people thinking, oh, I've got to learn so much stuff. To me, it seems like TDD is one of those ones that needs to be pushed to the front of the line over design patterns or other things. What's your opinion on new developers and when they should start TDD versus maybe something else?
I'm not sure. My son was in computer science education about 5 or 6 years ago, and he was, doing okay. And then I sat down with him on one of his assignments and said, you might want to think about writing these tests. And so he started to do that. And all of a sudden he went from and also ran to like the second in his class. And then, I also was teaching him a little bit about refactoring, although refactoring is this thing it takes, it's harder to teach because people don't know what good is. They might be able to detect what bad is, but they might not know what would be better. And, we kind of run the world on the, what I would call the aptitude test. If you can get the app to work, you might have an aptitude for developing software.
Nice.
But so my son would actually go to his professor and say, oh yeah, it works now, but I need to refactor it because it's kind of messy code. And the instructor would say, it doesn't matter. It works. You can turn it in like right now. And it's like, he came back and told me, it's like, the professors don't get it. You write code once and then you're going to I've seen 40-year-old code and I didn't write it. I don't think I have any 40-year-old code that's still running anywhere. I might have some somewhere, but so as a new developer, getting code to work is hard. And one of the things that happens is that systems work by accident. So you might get a feature to work, but you got it to work because this was wrong and this, function A returned the wrong value. Just imagine exactly the wrong Boolean value got returned. And function B looked at it and said, oh, if I change the sense of this if statement, then I can, and if you actually made those two mistakes and they offset each other, your code would work. And then if you get more dependencies on that wrong answer over here, which I'm talking with my hands, which the radio or the podcast listeners can't appreciate. Right. They fix that bug and then you break 5 other things. That's the telltale sign of that my code worked by accident. And I would like to set a higher bar for myself, which I'm striving for, which is my code works on purpose. And that kind of changes the way I work. I could tell you a little story about that if you're interested. Okay.
Absolutely.
So, well, you mentioned, how do we learn, with patterns and stuff? It's always good to see how other people do work. So patterns are a valuable thing to study. Now, I wanted my own website that I could customize for my business. And so at the time, Ruby on Rails was a big thing. And so I had a friend of mine help me get my website started. He gave me version 0.9. And then he was a new consultant. And then as soon as he got 0.9 done, my friend Dave, he got a consulting gig and I didn't really get much of his time after that. So I had to go figure out everything he did, which has been great. But I didn't know Ruby. I didn't know web apps. I didn't know Rails. There's all this stuff working against me. And I would go read the instructions on the Rails website about how to bring up a new web page, for instance. And it would say, do these 5 steps. And considering I had no idea what any of the 5 steps were, I would do all 5 steps. And guess how that would turn out?
It didn't work.
Yeah, it didn't work. It didn't work at all. And then so I'd spend my next day trying to figure out what didn't work. And I'd reread the spec, the procedure, and I go, oh yeah, this might be wrong. And I make that change. Read a little bit, run it. Nope, didn't work. That wasn't the magic. I'd go back and do it again. And eventually by 4:45 in the afternoon, magically the web page came up and I could take a break and, go to bed or, enjoy my evening. The next day, I would be debugging all the changes that I put in to try to get that page to work that weren't needed and were actually wrong. All right. So now I approach that problem much differently. If there's a 5-step procedure, and because of the TDD influence on the way I approach programming, if those 5 steps are actually in the right order, I could do no steps and see what error message I get. Okay, let's just try to get a web page that doesn't exist yet. And you get a 404 error. It's like, okay, I know what fail looks like. Now, the first thing it says is in Rails is to add a route. And so I'd go add a route, and I'd deploy my website again, and that route would be there. And then I'd get to that page, and it would say, you don't have a controller method. And it's like, okay, then I would go add the controller method, and then it would say, you don't have a view. And I'd go add the view, and it would say, hello world, and I'd have all the pieces, right? So I went from trying to look at it all and sprinkling mistakes throughout the whole thing, which is even in the places where I know what I'm doing, like in C or C++, I'm sprinkling mistakes all over the place. We're talking per minute, not per hour, not per day, the way we generate mistakes and stuff. And so because I know this about myself now, because of the test-driven development feedback loop, I work in small steps. So that means in C, so C is a compiled language with a linker stage. This isn't true of other languages. There's similar things in other languages, but in C, if I use a function that doesn't exist, I will get a very specific error message from the compiler. If I made the right mistake, and the only thing that was wrong with my code is that I tried to call a function that doesn't exist, I get a particular error message. If instead I made a different mistake, I don't get that error message, right? So I've taken my tiny steps to an extreme. So I get the error message that says, this function is not declared. Well, in C, that means you'd go to the H file and define the function prototype. And then when you run that, if you get a linker error, you know that your test and your H file agree. And then you get a linker, then you just go put an empty body, and then you see your test fail. That means your test is correct because, well, your test might be correct because it didn't pass if you didn't add any code.
Yeah. Right? It's getting to the right place in the call stack.
Yeah, we're getting to the right place, okay? And then, finally you go add a little bit of code to do what you want. And, the easiest way to get a test to pass is if there requires almost no code. And so this is why growing it from the beginning, it feels like a waste to people that never did it before. But in about a half hour, an hour, you've worked your way into the interesting part of the problem. And now all those little things that you put in place are protecting you. This is about the point where when somebody objects to the small steps of test-driven development, I'll say, well, how many problems do you like to solve at once? And they'll all kind of shake their head and go, 1. It's like, okay, well then how come you're trying to solve so many, right? Let's try and solve one problem at a time. And so if you can have this series of steps, it's kind of a challenge to envision, although I've got some help for you if you want to hear about about the help you might need. Zombies.
Okay.
Zombies can guide you through this process. And ZOM, 0, 1, many. There's a blog article on my website. Search for TDD Guided by Zombies. Its 4th anniversary was like 2 days ago at Halloween. But
nice.
So TDD Guided by Zombies. You start off with the simplest test cases. 0, meaning, well, the example I use is a FIFO, circular buffer. Well, what if it's empty? What if you just created it? What would be its? How could you interact with it? What could you do? Well, you could ask it if it's empty, and it would say yes. You could ask if it was full, and it would say no. Well, you run out of 0 tests pretty quick. What if we put something in it? Oh, then it wouldn't be empty anymore. Oh, what if we took that last thing out? Then it would be empty again. We're examining boundaries. Okay, so the edge conditions, boundaries. And we're defining interfaces. So the ZOM, 0, 1, many, boundaries, interfaces, exceptional situations, and keep it simple. There's a number of overloaded words for each one of those letters in zombies. It's not your typical everyday acronym. It's a kind of a multi-dimensional acronym. But so 0, 1, many. And then you kind of work after the interfaces are defined and you've exercised the edge conditions of 0 to 1. Then you start worrying about the general behavior in the many. And when you think you're finished, you take a step back, maybe the next day, and look at your work and see, what did I forget? Right? What exceptional things might be going on? And if people are interested in that, they could go, I think there's some online resources of me giving a presentation on the topic. And then there's a blog article with all the code and everything that people could take a look at if
I like that.
They're challenged on getting started.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
When test driving a particular function or a particular class and starting small, that makes sense. But you also talk a lot about managing dependencies when multiple things are going on and maybe you're testing 3 things together.
Yeah.
What's your thought process as you're going through there? How have you found to best explain that?
Yeah, well, so isolating responsibility. So having been a colleague, friend, and a mentee from Bob Martin for a couple decades. Well, actually, I've known him most of my career. My second job out of college was the same place Bob was. And so we've kind of worked near each other for a long time, continue to do some things together today. But the importance of managing dependencies and responsibilities was something that I learned from Bob. And so what's the responsibility of something? When you hear a requirement and you start to say the words of the requirement, you can sometimes notice different responsibilities pop out there. And you go, well, this should go over here, and this should go over there, and this should go over there. And so I'd like to use a UML diagram to kind of bucket the responsibilities. I know there was a lot of effort put into trying to use UML models to generate code, and I think that's a huge kind of wasted effort from what I've seen.
The old case tools?
Yeah, that tried that, and really code is a good mechanism for building code. Diagrams are a nice representation for getting people to think about the separation of concerns. So different people have different instincts with that. And that's, I think, the hardest skill of development is really what would be a good design? What is a good name? What's a good design? These are important things. If I think about the skills of refactoring, kind of dawned on me that there's kind of 3 critical skills there. And the reason I discovered there were 3 is because I was working with this team, and every other week for about a year, and when I'd show up with them on Mondays, they would say, here, look at what we did. We got all of our stories done. We got all these tests. We got 100% test coverage. It's great. And I'd look at it and go, oh, yeah, that's really good. This should go over here. Their feelings would be hurt a little bit. Oh, and this should go over there. They got everything to work, but they put it all in the wrong place.
Right.
And then after a couple cycles of that, they were kind of getting frustrated by it. Well, they knew that they were learning, but they would come to me on Monday morning with a list of all the stuff I wasn't going to like. And I said to them, it's like, oh, why didn't you fix it? It's like, great. Yeah, those are the things I don't like. Good job. Why didn't you fix them? He goes, well, we didn't know what to do. Oh, knowing what to do is a different skill than being able to detect something's wrong. It's like the dishwasher's broken. All right. Okay. What can we do about it? And so really this design skill, here's, I think, where mob programming and pair programming are so powerful, in that you can get the wisdom of the people you're working with and try different ideas out and see what works. And, to the best of your team's ability, you can produce the best thing your team is possible of if you work together. This is another this was the thing about the Agile Manifesto, which I didn't get in the beginning, but I totally get now, is the people side. Is it really to do, and Alistair was like hammering this in at the meeting. It's like, the process doesn't matter. It's who the people are. It's like, no, that's not right. He said, well, if you get good people XP, that would be good too, but if you don't have good people, that's a problem. You got to have really good people. It was interesting because a good person, a person of architect level experience on a team of 5 or 6 people will spread that knowledge throughout them if you're collaborating. If you're sitting up in a tower throwing down UML diagrams, from the ivory tower, that doesn't do anything. I've seen that model, and that doesn't work so well. But the rotating architect is a good model, because then you start solving problems. You hear how they solve problems and how they think and that sort of thing.
Mm-hmm.
So
yeah. Well, when it comes to dependencies that you talk a lot of, I see developers struggling because they will reach out to their package manager with NPM or any of the other package managers for all the different languages. They'll just pull in a library and they'll know exactly what they need to call in that library. And so then they'll call it. And
no, stop.
Right. So, putting that into, okay, if that's not the right place, how should a developer be thinking about just the process of pulling in a new library?
Sure. Well, if you depend on something that you don't control, you should write the interface you wish you had for the thing you want from that thing. So let's just say you wanted to find out what day it is and what minute it is. Now, most likely, this person building this embedded system or this Linux app or this Windows app or this whatever app can get out the manual and see, oh, here's how you get time. And there's a special H file in C that you would need. And then, and each one of those systems would be different though, because operating system, real-time operating system, FreeRTOS has one set of header files, and Windows Win32 has a different set of header files, if that's still a thing. And Linux has a different set of header files. And so as soon as you go and get that header file, now your code is tied to that thing. Now, something like, if you're writing Windows programs or if you're writing Linux programs, is there a huge risk in that, that they're going to change that? No, not really. But let's just say you wanted to move your program, you wanted to write something that worked in both those places. Now, what do? Well, we should probably depend on our own time library, right? So you could say, get me the time in a way that's independent of all those other things. Okay, now if I just go grab XYZ, so time is one thing because that's platform specific, but let's just say you wanted a JSON library or something like that.
Yeah, there's so many pieces of software these days are sending text messages.
Yeah, okay, so you want a text messaging thing. So the person that passes the aptitude test goes and gets, by my definition, right, app-tude. They'll go get that library. I mean, no disrespect, people. It's hard to get an app to work. Okay, don't take me out. Don't.
Oh yeah.
Don't. It's hard to get an app to work. It means you got possibilities if you can get it to work. But they take brand X's, and I'm worried about this for my website because I've done this because I didn't know better. Well, I knew better, but okay, at any rate, MailChimp API. I use the MailChimp API to send to subscribe people on my web that have joined my training classes, to subscribe them to my mailing list. So I have this API. Now, there is a place that knows it's MailChimp, okay? But most of my application has no idea it's MailChimp. It says, add these users to the mailing list. Underneath that interface, which I own the interface, which is add these users to your mailing list. Underneath the hood there happens to be an adapter that knows how to work with the MailChimp API. Underneath that is probably an adapter, the gem that I used from the Rails repository. I think it's called Gibbon, that allows me where I didn't have to invent the whole thing, but I could use their gem. But they may stop supporting it, right? And then I'll be in trouble. I could take the project over for myself because I could fork it, but I typically don't do that. But I have a little layer that protects my application from knowing that there should be a place that knows about that connection. So there's a general design principle here behind this thing, which is if you use something outside your control, don't use it directly. Wrap it and write an adapter, right? Make the interface that you wish you had and write an adapter to use the third-party thing that's, you want the facilities of. Typically, the third-party thing will have way more capability than you need. And so by just using a whole interface, this is the dependency inversion or interface segregation principle from the solid. It's another form of interface segregation. If you depend on a fat interface, don't. Depend on your own defined smaller interface and then write an adapter. Mm-hmm. So this is how I've kind of interpreted Bob's. Bob actually shows interface segregation through multiple inheritance. And in C, the way I translated that principle to C is, well, you're really going to introduce a adapter, an interface and an adapter between the thing that's outside your control.
Yeah, I like that way of explaining it. Now, for the developers who either inherited a piece of software or they've just been working with a system for a long time, and there's a lot of code that they're doing the debug later or just test over and over manual testing approach. How have you found is the most effective to actually start transitioning into a test influence, arriving some point in that system at test-driven development?
Yep.
But what are those steps in between?
Well, so I do a lot of training, and I'll just kind of describe what that's like. Maybe this is a plug. I don't know. I take people first for if I'm on site, which I don't do anymore because nobody does anything on site. Now I've been doing these 3-day remote delivered 3 half days, which is about the same content that we do over 2 days in a client site. I want people to see what's possible with test-driven development. So for starters, I start them in greenfield. What would really nice code look like? What would tested code look like? What are the steps of test-driven development? And so we go through an example so they can get the feel of that and the tools that they would need. And then usually the biggest concern they have at the end of that is, but what about my code? It's like, okay, so now I went to the Michael Feathers School of what do you do about legacy code. Michael was part of the Bob Martin's object mentor gang around the turn of the 2000s, turn of the millennium. And Michael's advice is, follow the Boy Scout rule. If you're going to make a change to the code, you need to make it a little bit better. Now, what does make it a little bit better mean? Well, Michael would say, you're not really sure what that code is doing, so you should write some tests for it to make sure you know what it's doing. Now, this can be really hard. If the code has dependencies, and you especially concrete dependencies, and you don't control the interfaces, and people make their interfaces final and stuff like, because that's a thing in C#, right? Okay, so if you depend on things,
C# is final by default. You have to mark it as virtual.
Oh, okay, all right.
But they're doing a better job of putting in a lot of first class interface abstractions. But either way, that still doesn't solve the problem. You still don't control what it is.
Yeah. So you've got to start. Well, so here's the typical problem on the first day of my legacy code workshop when I'm on site with somebody, or if we're doing it remotely, is to say, well, what class do you want to test, or what function do you want to call? And you start with the test case. There's a procedure on my website for C and C++ programmers to follow for this. I call it crash to pass, but we have to decide what are we touching? Okay, so I'm creating an instance of an object. Okay, I need to test one of the functions on the foo object, so I need an instance of foo. So the first thing you do in your test case is try to create an instance of foo. Now, this is usually a big problem because of the dependencies of foo, especially in C where header files, or C++ with header files. You end up getting all the stuff that has, all the dependencies of foo into the test file. Now that hurts, and sometimes it's impossible. Well, not impossible, because there's all kinds of hacks, engineering techniques that we can use to get C and C++ into a test environment, which we'll do another talk about that one day. kind of the short answer is drag your code into the test environment. Let's just say you're fixing a bug. Write a test to try to reveal the bug. Now, that sounds easy for me to say this. It's really hard to do if there's out of control dependencies, because now I might have to make some code changes to enable testing. So if there was a direct dependency on a third-party library, which is now getting pulled into the test environment, it's causing me a problem because it talks across a network. I need to do something. So I think in C# and in Java, you could do, I'll use this Java terms that I kind of remember, class path manipulation, which is kind of like linking in C and C++, where you have a binding at build time rather than dependency injection, right? So if I had a concrete instance of an object, I could just make a link time fake of it, right? Now that might be something you'd have to do when you're trying to drag this code in, okay? Or maybe you're going to have to find a way, if the constructor does a new of an object,
yep.
Well, that's a problem, okay? So you might introduce a second constructor so you could inject that thing and have it be a null or a fake or a mock or something. Now, mocks, when I say mock, I'll say, please avoid using mocks, and I mean capital M mocks, to all of you new people to test-driven development, which let's put that one to the side. But so someone would, it's a very pragmatic activity. Can I write a test for the thing I'm about to change? So I've revealed this bug now with my test. So I've gone through the trouble of pulling this code in the test environment. I've revealed the bug. Do I just fix it? No. Michael suggests, and it's a great suggestion, write some other bugs around the area because there's probably a nest of bugs there. And even if there isn't a nest of bugs there, you don't want any...
You meant write some other tests around the area, right?
Yeah, tests around the area. Yeah.
Yep.
Okay, thanks. I probably said, I mix up the words from time to time.
Yeah,
Good to have an active listener. So you would want to characterize the area you're about to change because you don't know why it's the way it is, and it needs to be the way it is, and you want only intended changes, no unintended changes. Here's this working on purpose thing again. Good job, Michael. And right, and so we would put some other tests around there and then make it safe to make our change. Now that you have some tests, you could start to free up. You could start to refactor the code as well, now that you have some safety. And I think C# is a regular language where you probably have some automated safe refactorings, in which case, if people know what a better design was, they could start to use those too. But, those only get you so far. Test cases are, dynamic analysis.
Well, you mentioned one thing. You go into a piece of code and initially you don't know how it works. Well, by spending the time, you actually gain the knowledge at that point in time. You finally figure out, okay, this is what this thing is actually doing. And if you just go on, well, now you forget one, or the rest of the team, now there's no way for them to capture that knowledge. And that was hard-fought knowledge of, okay, now I understand how this piece of code works. Whereas with the tests and refactoring, that knowledge could be captured and preserved.
Yeah. Well, I will add to that. You've inspected the code and you think you know what it's doing. And I'm going to put in italics think because you're probably wrong. Not until you've gone through the analysis and then written the test to confirm are you actually qualified to make the change to that existing legacy code. That's kind of my perspective on it. You actually think it works one way. You've got to verify your thinking by writing the tests. And then once you've done that, well, you get this long-term memory, which I appreciate your perspective on that because that's one of the things I try to get people to appreciate. There is the aid to our incapable minds to keep track of all these details, at least actively at the same time, right? It's just not possible. People aren't good at that. But yeah, definitely. You become qualified to make the change that you've been tasked with changing by exercising the code in a test. Mm-hmm.
Yeah, that's so important. Well, we could go probably for another few hours on testing and whatnot. We'll include all of your links in the show notes for people who want to learn more. But for people who have not yet really done test-driven development for themselves yet, what would you leave them with as a guidance for a next step forward?
Well, it's not a very straightforward thing to do. It's not intuitive. I'm very amazed that Ward and Kent figured this way of programming out because it's so effective. So I would say find somebody that does it and is enthusiastic about it to help you. Sit down and pair with them. Come to one of my training classes. I simulate that activity where you're pairing. Yeah, that would mean you're interested in C or C++. Okay, which maybe you're not. I might expand to some of the other languages. I'm building self-paced training right now, which all the words that get spread around it are different. The exercises could be language specific. So I'd say find a friend. The thing not to do would be to go read all the articles about all the people that didn't really ever do it that have opinions on why it doesn't work, because pretty much your opinions on why it doesn't work are not. It'd be like me commenting on ways to cook. Right? Like I don't cook. So, I mean, I can do breakfast. Right. I can do the barbecue and breakfast. That's it. Okay.
Hey, white rice requires 2 button presses.
Yeah. I mean, if there's instructions, I can do it. Okay. Yeah.
Awesome.
Yeah.
Hey, well, thanks, James, for coming on the show. This is fascinating. I appreciate your time.
Yeah. Well, thanks for having me on, Jeffrey. It was really great. Really appreciate it.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.